Welcome everyone to MATLAB Expo 2022. I'm excited to have such a large group of engineers, scientists and educators tuning into this talk today. In March this year, an ice shelf the size of New York City collapsed due to record high temperatures in Antarctica. It's a symptom of the climate crisis that will affect all of us. Already millions have had their homes or businesses damaged. And people are losing their lives in fires, floods, droughts, and storms. I'm deeply concerned about the world that my children will inherit. The climate crisis is here. But people around the world are stepping up to help. We can't leave tackling climate change to the climate scientists. Every industry must transform, and we all have our part to play. Many talented scientists, engineers, and educators are tackling the climate crisis with the help of MATLAB and Simulink. There will be three parts to the talk. I will start with research and show how scientists use data analysis, cloud computing, and AI to accelerate our understanding of climate change. I'll move to industry, where engineers also use AI, plus modeling and simulation to electrify everything. And I'll finish with education, looking at how educators are training up the next generation to tackle the world's big challenges. Let's start with research and accelerating climate science. This is Professor Michael Mann, the director of the Earth System Science Center at Pennsylvania State University. He contributed to a report by the International Panel on Climate Change. Their work was recognized by the 2007 Nobel Peace Prize. This included the influential hockey stick graph that tracks global temperature change over the last 1,000 years. His work uncovers the climate change signals within noisy time series data. This plot is from his paper on smoothing climate time series. Annual temperature recordings in the Northern Hemisphere relative to a mean temperature are plotted in purple. The data is noisy, and the trend has been uncovered by the two smoothing curves in blue and red fitted to the data. Both show a clear increase in temperature since the mid-1970s. Professor Mann leads by example by providing links to the data and the algorithms he develops. This practice is a key principle of the open science movement. Another key to accelerating research is facilitating collaboration. Scientists build on the work of each other, and cloud computing makes this easier. I opened this talk with a recent ice shelf collapse in Antarctica. When ice shelves collapse into the ocean, it can accelerate the flow of glaciers on the land, contributing to sea level rises and coastal flooding. Scientists use satellite data to study shifts in the ice, and this data is often stored on cloud portals. This image is from Copernicus, the European Union's Earth observation program. Copernicus provides a popular cloud portal for climate scientists. Datasets shared on cloud portals can often be huge, and the data analysis can be time-consuming. Parallel computing can reduce the execution time of your algorithm and deliver your research results more quickly. The pace of discovery can also be accelerated with AI that helps to uncover the patterns in datasets and build accurate predictive models. In this next story, 4 climate scientists from Canada and Algeria collaborated to predict drought accurately. They studied the Awash River basin in Ethiopia. Here, people are heavily dependent on agriculture to make their living. Drought is a common occurrence, and it can cause crop harvests to fail. It makes the local communities extremely vulnerable. But if you can predict droughts accurately, then their impact can be mitigated. Droughts are measured via a standardized precipitation index, essentially a measure of rainfall. The researchers predicted the measure we see on the screen using techniques that had never been coupled together before for drought prediction. These techniques are artificial neural networks, support vector regression, and ensemble methods called bootstrap and boosting. The researchers also used wavelet analysis to pre-process the time series data, which gave more accurate predictions. You can see how the model prediction in red closely tracks the observed precipitation index in blue, indicating an excellent fit to the data. This is a good example of applying AI techniques to predict drought. In this research section, we heard about how scientists use data analysis capabilities to model temperature increases, cloud computing to analyze satellite images of sea ice, and artificial intelligence to predict drought. Climate science helps us understand the trends and the impacts of climate change. But when it comes to tackling the climate crisis, we need engineers in industry to step up and electrify everything. Eunice Newton-Foote was the first scientist to experiment on the warming effect of sunlight on gases. In her 1856 paper, she theorized that changing the proportion of carbon dioxide in the atmosphere would change its temperature. And she was right. Climate change is occurring because of increasing levels of greenhouse gases in the atmosphere. To tackle climate change, we need to reduce our greenhouse gas emissions. These emissions come from every industry sector. To limit the devastation climate change will cause, every industry needs to transform and reduce harmful emissions. This will take significant innovation, and engineers are stepping up to meet this challenge. In fact, there is a huge array of possible solutions for reducing greenhouse gas emissions. Two areas we will focus on today are generating electricity from renewable sources and using that electricity as our primary energy source. I'll refer to this pairing as the electrification of everything. Nearly a quarter of the world's greenhouse gas emissions come from electricity production, and it is a key driver of the rapid increase in greenhouse gas that we've seen in the past century. 140 years ago saw the start of an engineering transformation, the growth of the electric power grid. Access to electricity improved the quality of life for millions of people around the world and kick-started the global industrial revolution. Increasing access to electricity continues to drive economic development today. But the growth in the electric power grid was driven by burning fossil fuels, a process that emits a huge volume of greenhouse gases. And unfortunately, 61% of the world's electricity production still comes from fossil fuels today. Fortunately, however, that proportion is falling as the world transitions to more renewable energy sources. The increasing green curve representing renewable energy on this graph gives me hope. We need to produce electricity from renewable sources such as wind, solar, and tidal energy. Let's look at how AI plays a role in this transition to renewable energy with an example from Korea Institute of Energy Research. Offshore wind power is a key part of the renewable energy transition. The cost of offshore wind has decreased by 50% in the past decade, helped by increased capacity and improved efficiency. An efficient operation relies on effective maintenance. You need to be able to accurately identify when a component needs replacing. And this is especially important out at sea. If you don't schedule enough maintenance work, then you run the risk of an accident. But if you do too much maintenance work, then costs increase and less power is generated due to downtime. Predictive maintenance models can help. A typical turbine consists of approximately 8,000 components, and many of these components are fitted with sensors. Across multiple turbines, the researchers analysed thousands of signals from these sensors, including wind speed, turbine rotational speed, and power generated. They pre-processed the sensor data by removing outliers and performing smoothing and data reduction. For example, by eliminating sensor measurements taken when a turbine was stationary. The team implemented a variety of machine learning algorithms, including regularized linear regression, polynomial curve fitting, and decision trees. They also implemented and trained an artificial neural network using deep learning. The researchers evaluated each algorithm's ability to predict the loads on key turbine components, such as the bending moment of the blade, the shaft tilt moment, and the shaft yaw moment. The engineers used these predictions to anticipate when the load on a component was likely to exceed the recommended limit, and to estimate the remaining useful life of each component. And the results were excellent. Despite limited experience with artificial intelligence techniques, the research team were able to develop an algorithm capable of detecting component failure with over 90% accuracy. Finally, to help their colleagues monitor turbine operations, the engineers created and packaged a dashboard for the algorithms. The workflow had multiple steps: data pre-processing, model development, and deployment. This is common with AI applications, and MATLAB supports the full AI workflow, which includes accessing data from sensors, files, or databases, analyzing, pre-processing, and labeling data, developing AI models, and deploying the models to desktop apps, enterprise systems, or embedded devices. MathWorks supports many of these steps with apps that require no coding, which makes AI accessible to everyone. This offshore wind story highlighted the application of AI to reduce greenhouse gas emissions in electricity production. But significant greenhouse gas emissions come from many other sectors, including buildings, transport, heavy industry, and agriculture. These sectors all need to transform to reduce their harmful emissions, and electrification has a big role to play. We need to electrify everything. Let's dive in to an example of how steel production can be electrified with the help of modeling and simulation. Steel is the most common structural material used in almost everything around us. It is an essential but environmentally hazardous industry. While technology has seen major advancements across most industries, the process of steel making has remained much the same for thousands of years. And this is what it looks like. Mix iron and coal within a blast furnace to create molten iron, followed by a process to remove impurities. This results in a significant amount of carbon as a byproduct, about 10% of all global CO2 emissions annually. With the continuing growth of steel production, we are left to wonder who will be tackling the next generation of changes in this industry. Boston Metal is a startup with the answer. The team is transforming the steel industry with their groundbreaking technology aimed at producing steel in a greener and cheaper way. The patented technology, molten oxide electrolysis, replaces the traditional processes by using direct electric current to separate chemical compounds. The method produces liquid iron with a byproduct of oxygen instead of carbon. It's a cleaner and simpler process. And if the electricity being used comes from renewable sources, then we can drive overall emissions towards zero. A model-based design approach enables the small team to work efficiently. They built a full dynamic model of the control system, which allowed the team to model and test the system against the digital twin, ensuring that when the team was ready to turn the system on, it worked. The engineering team at Boston Metal is no stranger to the challenges startups face. They have limited time and resources with huge milestones to hit. To overcome these challenges, they participated in a program that provides startups with access to MATLAB, Simulink, and more than 90 toolboxes at a startup-friendly price. Engineers at startups need to innovate quickly, and domain-specific examples help them get started in new areas. MathWorks provides examples to help engineers in all industries adapt to the electrification megatrend. These include component examples for quick and easy simulation. An example is battery charging and discharging. Reference examples that support system design, for example, a model of an entire automotive electrical system. and design solutions that provide adjustable models and demonstrate a full workflow, for example, to support the design of a wind farm. I get so excited when I hear about all this incredible work being done by engineers to mitigate greenhouse gas emissions. In this industry section, you heard about the application of AI to the predictive maintenance of wind turbines and the use of modelling and simulation to electrify steel production. To tackle the challenges of electrification, industry needs a strong supply of engineers with the right set of skills. In this final section, let's look at how educators are training up the next generation of engineers and scientists to tackle the world's big challenges. Robert Bosch Engineering India realised that new graduate engineers coming into their company required up to a year of training before they had the skills needed to be effective in their electric vehicle programs. To help them address the shortage of skilled engineers, they decided to create a new university course to teach model-based systems engineering. They partnered with NIT Calicut in India and MathWorks to develop a suitable curriculum. This picture is from the signing ceremony. Together, we built a course covering EV fundamentals, such as regenerative braking, energy storage, and electric drivetrain systems. This theory was brought to life through hands-on modelling and simulation of EV systems, giving students the opportunity to build their practical experiences. The educator and student feedback from the course was excellent. Harry Bhaskar was one of the students on the course who now works as an electric vehicle systems engineer at Bosch. The course was a personal turning point for him in his understanding of the world of engineering. Like many educators, I love to hear stories of students going on to successful careers in industry. If you are an educator training the next generation, then MATLAB courseware can help you. These downloadable materials help you develop and enhance curriculum, facilitate lectures with examples, and inspire student learning. We have resources and ideas to introduce computation in your courses. Courseware exists for many disciplines, including electrical engineering and earth, ocean, and atmospheric sciences. And there are pages with resources for teaching specific subjects, for example, teaching data science with MATLAB. Completing the triangle, educators also want to build student research skills. A common way of doing this is via final year design projects, but it is challenging for educators to provide project ideas that are exciting for students and up to date with the latest research and industry trends. This is where MathWorks' Excellence in Innovation programme comes in. This new programme provides a collection of over 50 inspiring projects that students can choose from. Technology areas include AI and renewable energy. Students sign up and receive a certificate upon completion. Dedicated discussion forums are available for each project to help students learn from each other. The project shown here relates to rising sea levels. In the project, students use mapping capability to develop a function to calculate and visualize coastline changes. The project description suggests suitable cloud-based climate data sources to use and provides pointers to background material and examples to get them started. This project improves student skills in data analysis and gives them insight into climate science research. That concludes our final section on education, where you heard a story of collaboration between industry and academia to train engineers for careers in electric vehicle development, and learned about the MathWorks Excellence in Innovation programme that develops student research skills through project-based learning. I hope you've been inspired by the stories you've heard today of scientists, engineers, and educators playing their part in tackling climate change. We've seen how data analysis, cloud computing, and modelling and simulation accelerate research and electrify everything. And you might be wondering, how can I increase my skills in these technologies to help me with my work? You can get started with MATLAB, Simulink, and Simscape with 2-hour self-paced tutorials called on-ramps. You can also learn the basics of machine learning, deep learning, and circuit simulation. Full online training courses are available when you need to go deeper. And MOOCs, massive open online courses, support continuous professional development. For example, this program on solar energy from the Technical University of Delft. My personal climate journey began at a conference like this one. I watched a powerful speech by a young woman whose message was believe the science and act. In the coffee break, I had a transformational conversation with an expert climate educator. I realized that the most impactful thing I can do about the climate crisis is to accelerate the work of MathWorks customers. And that's why I'm here with you today. We can't leave tackling climate change to the climate scientists. The imperative to reduce greenhouse gas emissions requires the transformation and electrification of all industries, including yours. Think about what you can do to help. If you're a scientist, accelerate your research with AI and cloud computing. You can use an extensive library of AI models and cloud-based workflows in MATLAB to help you. If you are an engineer, electrify everything with modeling, simulation, and the full AI workflow. You can join MathWorks Startup Program or use reference examples to innovate quickly. If you are an educator, train the next generation with project-based learning and help students learn about industry and research applications. Leverage our courseware and collection of student research projects to adapt your curriculum. MATLAB Expo is a fantastic opportunity to collaborate across research, industry, and education, and I encourage you to take full advantage of the event. If we apply our skills and knowledge as scientists, engineers, and educators, then we can save the Earth and move towards an equitable future together. Thank you.